Wapi? Ah, da, hongera bro. Ah, hiyo haikwepeki bro yani. Najua unakumbuka.
GM, guys, how's it going?
All good, all good. How's it?
Shwari mzee, mvua mvua tu kidogo, lakini tunashukuru Mungu. Let's just give it maybe like 5 minutes hivi for people to like join in, then we can start. Sema Amona
Yeah.
Baraka hapo going.
Yeah.
How's it going, gents?
All good, all good. Hope you're good.
100%. Nimekufanya uwe host, so you should be ready to go. I don't know if the session is recording automatically, but you should be able to record.
Yeah, I see it says it's recording, so I think
Yeah.
we should be good.
Awesome, awesome. I'll also just record to make sure. But yeah, I'll
Yes,
give it time and then we can start.
yeah, sema inabidi tutangazie vijana kwamba yo kuna incentive for end of the cohort or something to incentivize the guys to join calls as well as build some real world solutions, you know.
Kabisa, kabisa. We can also make a post about it on our communications as well.
Yes, sir. Yeah, I don't know if I should say this because it's recorded, but I just heard a crazy conspiracy on how tulikuwa tunaongea jana on how like it wasn't raining maeneo tunaoishi sisi and some guys wakawa nasema kwamba kuna conspiracy kwamba like Chinese guys is trying to stop the rains. They do this artificial thing, mawingu yakitokea mvua inyeshe ya maeneo especially ambao wanajenga jenga so that they can go with the construction, you know. But I just thought that's a crazy conspiracy. I just thought it was funny. Sema naona watu wanajienjoy hapa. I think we're 5 minutes in. I think Maringa, maybe you can kick it off. I think for the sake of time and the calls, I think itakuwa sisi to see like there's 8-9 of us here. We could just start. If people are gonna join, great. And yeah, the call's recorded. So over to you, bro.
Chuche, you should share your idea wherever you found that conspiracy. If there's any, it's a Twitter link or something. It'd be amazing to know more about that.
Yeah, it wasn't no Twitter link or nothing, bro. It was just stories up on a palace. No, no man, a conspiracy.
Yeah, I mean, they do that in Dubai. They did that in other parts of the world. So yeah, I won't be surprised, honestly. But yeah, I
Yeah.
see new faces. I see new people joining in. Karibuni sana. Yeah, as we're waiting for more people, we'll start literally on the 10-minute mark. While watakuwa uchelewa, they'll just find the recording and be able to continue. But yeah, we have some more exciting things coming up as we pick up the sessions. So if you join this every time, guys, there will be certification at the end. We'll build real life products at the end of this cohort, and hopefully something that works. And maybe we have some competition, have some prizes for people to win who can build amazing products. We'll keep communicating this. So I know the first sessions are boring. You gotta get to the nitty gritty, but yeah, it's gonna get exciting. So just stick in there, tuendelee kujifunza, tuendelee kukua pamoja. So karibuni.
Yeah, and just to put it out there, I think we should be having our first physical boot camp this Saturday, kind of physically. So kujiandaa tu hapo for that as well, so then y'all know.
Yeah, for sure. So yeah, I'm assuming everybody has a computer. So, but if you don't have one, let us know. We'll communicate this over the week, and we can arrange to find a location that can accommodate this. Or if not, we can also like put a forum out. If you have any suggestions of what do you think will be best times as well, in terms of like to meet again, tukutane physically, we'll share ratiba yetu. But yeah, let's use the chat to do that and build on that. But yeah, today's session itakuwa inaongozwa na Julius. For those who don't know him, he's gonna introduce himself and run the show as part of the core team. Wale ambao missed last session walijitambulisha. So we're super excited to hear from him and what he's prepared for us. So it's gonna be a very, very amazing session.
Yeah, Maringa, I think we can kick it off for now. Usually in a mood, David, and leave room for spaces and questions. And like kama siku zote should be like as interactive as possible. If there's any questions, just butt in and ask questions. So Maringa, over to you, boss.
Yeah, I'm sharing my screen. Oh, it shows the photos. Can you guys see my screen?
Yes, sir.
Okay. So, okay, my name is Julius Marenga. So I'll be talking more after the introduction of the last week. I'll be talking more about the architecture. So we'll have some things interconnecting there. Like nitajifunza zaidi kuhusu architecture, blockchain, kuhusu blocks, transactions, cryptographic, consensus, zaidi leo. So let's get started. So kama kuna mtu atakuwa na swali, you can just raise a hand or put in a comment. Tutasoma some which will need discussion, we'll discuss here, na ambazo zitaweza kujibiwa zitajibiwa pia hapa. So let's get started. So from the architecture perspective ya blockchain, then as from the introduction, we know kwamba lazima kuwe kuna blocks, and then the blocks have to be interconnected, so they has to have chains. So leo tunaenda kuona so what is within the block and what actually is the block na nini kipo ndani ya block. So block as inavyoonekana itakuwa ni batches of cryptographic verified transaction. Ni transaction lakini lazima ziwe cryptographic verified. So kwa hii so tunajua kabisa blockchain itakuwa kama kuna blocks, then we have cryptography involved and they have to be cryptographically verified. So later we'll know how this verification is happening as far as the blockchain is concerned. So the block it contains the header. So each block has the header, and on the header we have some details ambazo lazima ziwe included kwenye particular block. So kwenye header we have nonce, we have the previous, except from the origin, the previous hash inakuwaga ni 000, but apart from the origin block, when I say origin block namaanisha in any blockchain network lazima kuna ile initial block ambayo ilitengenezwa. So that's always called origin block, genesis block. So except from the genesis block, which has the previous hash inakuwaga ni 000 as to mean undefined, kwamba haipo. All other blocks ambazo zinafuata mbele lazima ziwe zina previous hash of the block, na lazima ziwe zina nonce, and they have the maker root hash. So the maker root, we'll go and discuss more about the maker tree. So, but each block has to have the maker root hash. Hii ni kwa ajili ya verification, and we will see later how this verification works. So just to be clear, so the nonce here is always for most of the proof of work consensus, huwa inakuwa ni the proof of work number, the number which is always being calculated as the proof of verification of that transaction. So that's all about the block as one part of the blockchain. So within the block, then after the header, we have transactions. And the transaction they become on the body of the message. Sorry. Oh, sorry. So transactions zinakuwa recorded on the ledger. So the transactions on the body include the transfer of crypto or execution of smart contracts. So if we have execution of smart contracts, we keep it as transactions. Or if there's a transfer of crypto from one user to another, we call it as a transaction, and it's being recorded as a part of a block. So after knowing the content that's been, so transactions being included in the block. So now we have the complete block with a header, as I said earlier, with all those informations, and then we have to connect the blocks to form the chain. So one component of the blockchain in general, after the block, we have transactions and we have the chains. So the chains are secure linked via cryptographic hashes. So hapa pia tunaona pia kuna repetition ya cryptographic. So we know one of the biggest component ya blockchain ni cryptographic. So we'll see about these cryptographic algorithms And each network, or most kuna some they use the same cryptographic algorithm, but most network each one use its own cryptographic algorithm. So, for that being said, then we have to discuss the cryptographic and how it works. So, at least in blockchain, and later on we'll see how this cryptography helps to secure the blockchain and the Merkle tree at large. So as we know, last time we discussed about the hashing. So hashing is one-way process that converts any data into fixed size or unique string. So that unique string is what we call hash. So down here we have the hashing algorithm that we have SHA-256. So some will know the MD5, and we have Ethereum. Ethereum uses this one, CAC256, for hashing. So given the string, you have to produce a unique identification of that string. So, and anything you change in this string has to produce a new string. So this is actually one of the components in the blockchain ambayo pia tukisema kwamba without cryptography na nikasema pia tusiwe na blockchain, kwa sababu blockchain inategemea cryptography kwa ajili ya yenyewe kufanya kazi. Unless kama kuna mtu ana swali can hear it, au kama kuna chati you can write on the chat. Kama kuna mtu ana swali you can or an addition. Yes,
mimi na swali moja hapo. I'm guessing the hashing for different layer ones natofautiana hapo, like kwa mfano Bitcoin umesema hapo uses SHA-256, Ethereum KK56. I know mostly about Ethereum, but like how does it work for other chains? Like does it have to end with a 256? Because I'm guessing hizo hapo ndo zile uint.
Yeah, I know. Kwa chain sio lazima uwe na 256 kwa sababu actually hizi hashing algorithm ni zina evolution, and the more bytes, and this number also stand for bytes ambao zinatumika kufanya hiyo hashing. So the more or the bigger the bytes, so inaonyesha kwamba inaongeza security to some point, right? Kwa hii 2562 ni number of bytes ambao the particular algorithm ina use, na kwa sababu most of them this one like SHA existed before Bitcoin, right? So it was not made like for Bitcoin, so it existed, and there is another algorithm ambayo inatumia even more bytes than this. So it's not necessarily kwamba ita end na 256, kwa sababu this just represent the bytes being used in the hashing. Does that answer your question, Chuche?
Yes sir, yes sir, thank you.
Okay, good. So let's kama kuna mtu tena ana swali au anataka kuchangia. Okay,
Yeah, kuchangia tu. I think watu utaelewa zaidi hizo bytes.
Actually, so
okay, I think okay.
Yeah, just point of correction kidogo hapo, sio bytes ni bits.
Yeah, thank you.
Yeah.
Kweli sikupigi mzee.
Thank you. It's bits. Yeah. So you could calculate the number of bytes that I think you divide by 8. You get the bytes. So thank you, Ntilo.
Yeah, I think we also have like a specific workshop for that. So kwa wale ambao bado hapo I think wataelewa zaidi hapo.
Yeah, we can do the bits and bytes differentiation there and okay, thanks. So what's the role of, as you said, tumepiga story hapa, tumesema kuhusu hashing na nini. What specific role does it have in blockchain, na kwa nini ni core component? So kwa sababu na tutafanya ile the most famous demo ya blockchain, we'll see how this interconnects. Lakini kwa sababu tunavyotengeneza a blockchain, as an introduction said, tunasema the next block count the component of blockchain has to be the previous hash. So hashing the contents out the body of the hashing to get the hash of the next block, au kuwa na hash ya next block kuwa reference to the previous block, inaonyesha umuhimu wa hashing kwenye connect these two blocks or consecutive blocks na following blocks kuweza kuprevent tampering, kwa sababu hash ukiweza kuibadilisha any detail or any information, since it changes the whole hash, then all the following or the coming blocks nakuwa invalid, then inatufanya kuweza kupunguza tampering in so saying. So na tukatoa mfano kama Bitcoin block header it has hashing for proof of work. We'll see more about the consensus na practicability zake. So kingine hashi ni collision properties za hashing, lazima like for good hashing algorithm, na mara nyingi the one way ambao unasema kwamba you have cracked a hashing algorithm ni umeweza ku create like given your data labda let's say a string a string hello world, ukaweza kuproduce the same hash for different string, then unakuwa umetengeneza collision. So with the collision ile hashing tayari inakuwa invalid, kwamba it can create the same string with different, it can create the same hash with given two different strings. So mostly algorithms inakuwa tested hivyo. You have to give it string, and for each string inabidi it produce the different hash. So the properties kubwa ya hashing algorithm au property ambayo inabidi iweze kufikiwa ni isiweze kuwa na collisions, na ikisha na ukiona imekuwa most zinakuwa change kama hizi MD5 MD5, they are changed when they have collisions, and has to have speed. Inabidi iwe na uwezo mkubwa given the content, sababu inaweza hash document strings, iweze kuwa na speed kubwa. Na pia important feature nyingine ni avalanche effect, and the avalanche effect ndo what I said. If you write hello world here, if you hash this hello world and it gives you this specific string, nikibadilisha maybe a d nikabadilisha whole world nikasema hello work, isionyeshe specific kama imebadilisha labda 7 na 9, but it should change the whole string completely, kwamba hata nisiweze kuitambua kwamba I've only changed the two letters. So for hello world and hello work, they should not even have a way kwamba nika track they are somewhere closely related. So that's avalanche effect. Even a space or a nuke or something iweze kubadilisha the whole string completely, ili hata kama ni mtu anataka kufanya sijui kutengeneza similar hash asianze kuwa anafanya tracking. By tracking means kwamba okay, if I change a small letter nimepata hii, okay, let me change this small letter, nitaweka hapa 9 ngapi, hii niweze kupata another hash. So hashing algorithm inabidi ziweze kuwa na at least these properties kuweza kuwa viable or usable in any way where hashing is used. I don't know if this chat is a question. Let me just go and read it. Okay, if you guys have any question or something to share on the role of hashing and the properties of hashing, there could be some more properties. Please, you can just unmute and say something. Question, something to add on the hashing, especially on the property. Yeah.
And something to add is, I think ni vizuri kufikiria, like to think about mambo ya hashing. If you're somebody that did mathematics in O levels from 3 pale, kuhusisha concept ya hashing na one-to-one functions. So ideally, a hashing algorithm should work there should be, for example, if it's a string, there should only be a certain string produced by the hashing algorithm that is identical to that string that you've inputted to it. So ni kuna representation moja ina reflect kwa nyingine, but nothing else can be in that. It's not one-to-many, it's just one-to-one function.
Thank you. Yeah, thank you. Thank you for that, Ntiro. It's one-to-one, and that definition was, let's say, is a one-way. You give something to produce something, and that's all. It has, okay, so we have also some signatures. So, and there's something skipped here. So on the hashing, on the blockchain, some other components when we discuss the architectures, it's the how you do you sign the transactions. By signing, I mean how do I keep track this particular transaction has been done with someone here in the team and it's not done with me, or it's done by someone. How do you prove the ownership? So we have the concept of private and public keys, and in the blockchain we use them to do signing, and they'll have so many rows of them in the next slide. So actually in blockchains, or when we create wallets, we have the public key, which is being used, or it's publicly known to everyone. And below the public key, we have the private key. We have the private key, which is a secret. So using the private key, you can construct the public key to be used or to be known in a public way. So it could be, consider au tufikirie transaction ya kutoka mtu A kwenda mtu B. So mtu A how do you prove the ownership? Mtu A ana private key yake na public key yake. And mtu B anakuwa na public key ya mtu A. So mtu A anasema I have done something, or anafanya particular transaction, then they have to sign them with their private key. Then kwa mtu B, ili kujua kwamba hichi kitu kweli kimetoka kwa mtu A, inabidi akiverify using the public key ya yule mtu A. So this is how it works. So kwenye digital signatures, or depend na different digital signatures ambazo zinakuwa used, zipo varieties, lakini at least kwa hapa what we're just using public and the private key in management of the wallets or signing transactions in the blockchain. So use the private key to sign, and use the public key to verify the transactions. So the purpose of signatures in the blockchains, you have to authenticate the ownership and the control of a crypto wallet. So if tukifanya labda Saturday workshop ya kufungua wallets, then you will have more idea of what the private key and the public keys are, and how you can manage, or you can use those keys to manage your cryptos. So because blockchain inatambua kwamba with these keys of this particular RSO key, ndo imekuwa binded with this amount of crypto something. So inatambua ownership wa these cryptos ziko kwa huyu mtu fulani. So they're used to authenticate the ownership. Na pia they are used to secure transaction by preventing unauthorized spending. So you cannot spend something you don't have in your wallet, right? So now it ensures integrity and trust in the decentralized system. So mostly in the decentralized system, particular kwenye system ukiacha hata kama sio hela, labda kwenye system kama za kufanya unafanya digital signature labda kwenye document, unataka kujua hii document ilikuwa digital sign na fulani, so you have to use the keys to verify. So using the public key combination ya ile document iliyokuwa signed na ile public key, it can verify if this document has been signed with the person or not. So with that being said, it can ensure kwamba tunajua kuhusu integrity ile document, kama je ni sahihi au imekuwa tempered na vitu kama hivyo. So the other thing, okay, from the digital signature, someone could have something to add or a question. With the public and private key, I think there could be someone to add something, depending on different understanding our analogy. So if someone wants to add something.
Yeah, not much really. Lakini I think for signing transactions, kwa mfano, I think most people, they sign transactions when it's a financial transactions. Kwa mfano, nalipia gas fees pale, lakini kuna transactions where you can sign without paying for gas fees. Ndo kama hizo amesema Marenga hapo, like signing a document, for instance, or like if you have to review something and you have to do it on chain, basically anything on chain that you have to do on chain, you have to sign a transaction and get a transaction.
Yeah. And I think we'll see this hata kwenye some third parties kama wanataka to interact with your wallet. Sio necessarily kama unatuma hela, but they have to ask you to sign to see if you're the owner of that wallet, na kuwa ujua ni kama vile some third party use it as a authentication process. You sign and then you agree to sometimes. Yeah, so I'll speak, tutaingia kwenye market tree na tutaona what is it na how is it necessary kwenye blockchain, namna gani inakuwa necessary, at least when we speak about the architecture in general of the blockchain. From the blocks we said, tumeongea blocks, tumeongea transaction, tumeongea the chain at large, tumeshaongea kuhusu algorithm hashing, and tumekuja kwenye key pair management, the private and public keys, and then tunakuja kuona the macro tree. So macro tree, maybe if I got the diagram first here and then nyuma kidogo. So macro tree, consider analogy yake ni chukulia tu kama mti, then mti unaanzia kwenye roots, then una shina, roots na shina, and then unakuwa na branches, and kwenye branches alafu kunakuwa kuna leaves. All right, so it's called tree kwa sababu inafanya kazi kwa kutakuwa. So kwenye the same as a macro tree, kunakuwa kuna roots, as we can see we have the root hash, and then we have, let's say these are the branches, or hii ni shina, and then kuna hash za hizo branches, and then kuna leaves, na kwenye leaves pia kuna hizo transactions and the hashes za hizo transactions. Sawa, kwenye mti inaweza kuwa kuna leaves ambao kuna hash ni transactions, na pia kwenye branches zile pia ni hashes za transaction ambao zipo kwenye zile leaves za the specific branch, na pia kwenye root ni hash ya the whole branches and leaves imekuwa hash pamoja. Hiyo analogy na make sense. Before alianza kuongea sana how is it okay, I will say how is it relative kwenye blockchain, and then baadaye I think I will invite someone to say more how they understand it in any context they want. So for the macro tree is a binary like structure. So binary is like unakuwa na shina, you have one expands to two, and then this one expands to two, this one expands to two. This is how binary structure, like it's a binary structure, so made up of hashes. So we have the leaf nodes. So kwenye macro tree we have nodes. So the nodes, na kuna parent nodes, kuna node, na kuna zile leaves kule juu. No. So leaves node ni hash of individual transaction data. So each transaction data inakuwa hash and it creates a leaves. Ina create matawi kule juu. Then parent nodes ni hashes za concatenation ya zile child hashes. Alafu kuna ile final make root inakuwa at the top ambayo ni single hash na represent all transactions in a block. Sawa. So how is it pointer tunaitumia kwenye validation. Kabla jenda kwenye slide, I will just explain to just an overview how this is being used, how this works. So unataka kujua we have like millions of transactions ambazo zina happen kwenye blockchain network. Sasa unataka kujua kama kuna kitu kimekuwa tempered, maybe a single transaction labda kama if there is a single transaction maybe has been tempered in the network. So most likely you have to go through all the transaction hashes na uangalie kama they are correct or not. So wakagundua kwamba this will be the process itakuwa inachukua muda sana. So they create this thing they call a market tree, kwamba instead ya kwenda kuangalia on single transaction, single point, kuangalia kama kuna, if you want to do validation, you can do validations on the roots. Whenever something changes on the leaves, the root hashes have to change. As we tumesha agree kwamba hashing kitu kichange, then the root has to change also. So whenever something changes on the leaves, we know kabisa the root also hash has to change. So kama umeweka data zako somewhere, you probably have to keep track only on the root, just to know if the data kuna integrity au hakuna integrity. Because if something changes on the hash, on the leaves, or on the parent hash, you know the root will also change. So Markov tree allows for efficient transaction verification without downloading the entire blockchain. You just need to keep track of the Markov tree. So using the Markov proof, you can prove that the transaction exists in a block by checking a small set of hashes up to the root, rather than checking all transaction. Na kitu ingine pia, you want to track the transaction kama ina exist, kwa sababu ile Markov tree ni hashes ambazo zinakuwa like zinakuwa na preceding prefix, like how you do, I don't know if you know the concept of geohashing. You do precedings or prefix. You want to track a transaction down the route, then you'll be nimekuja na transaction I want to track down the route. Then if kama nishajua kwamba ipo kwenye namba yake ni hii, I know nikianza from choices, I'll start from here. If I know the initial numbers, I'll choose between maybe these leaves. I will know it's not among these leaves, it's in this leaf. Then I don't have to check on this. I'll have to go down here. Kwa sababu nitakuwa eliminate hii or this thing on the checking. I'll check this down here. Then tangala preceding prefix no fata baila to check this and this. I want to know ni hash 1. Then I'll go down to the root. But kawaida, if I want to check on the whole blockchain data, I will have to check every transaction. But I now have to know the hints. Then from the hints, I can track down the transaction kwa kuangalia tu, kwa kuangalia this binary zilivyokaa, nikasema okay, is number zake zinanielekeza hapa ni transaction number 4. I don't have to check number 3. I just have to go down. It's here and here. So this algorithm or this kind of thing inanipunguzia kazi ya kucheck the whole thing. Probably we could have much broader, but it will give me a one-way checking down to the root. Okay. So
Yo, I have a quick question there before we proceed.
yes.
Maybe what's the difference between Markov tree and Markov proof?
Oh, okay. If someone can help me to say I don't know about the Markov proof, but probably someone in the audience. Zero. But I know the Markov tree, it helps you Markov tree looks like a structure that helps you to check down the blockchain data bila kwenda kwa kila transaction. So you just have to check the prefix na kwenda down, and probably Markov proof not ahead of it.
Yeah,
So,
naonaga kwenye
yeah.
auditing sana sana baadaye. Nimeona Asante hapo
Yeah.
Yeah, so a Markov proof, it's now it's what proves that like the tree is there, I mean is correct, without showing the values inside the tree.
Okay. So what does it use the same the root hashes something?
Because you see with a typical tree, it's going to be, I think a big O notation is like log n.
Yeah.
But easy Markov proof. Okay, let me say it's ndo hiyo kwamba it's data that's included in the Markov tree without revealing what each leaf is. Lakini deeper explanation itabidi nikaa nifikirie kuhusu deeper explanation.
Sure. Maybe we can keep it as a question in the say. Also, I'll also find the difference between the two, because likely nilikuwa nafikiria will be the proof of the Markov tree. So
it's got something to do with ZK, mambo ya ZK hayo ujue ni mazito.
Zero knowledge. Sure. So yeah, as we know, kwa sababu you don't have to check the whole blockchain, so it's a quick and scalable verification, very quick, yeah. I think Asante ume mention about the log. I think in the programming we have that thing, searching algorithm ambayo, you before you go to search on the something, you divide it into half, then unaangalia kama is less, the number is less or more, and then if it's less, you choose the other half and leave the other half. So it leaves every time you be searching, inakusaidia unakuwa unaacha the whole half bila kwenda kufanya a single searching ya kitu. So I think this design pia kwa sababu pia inakusaidia kwamba at any time unapokuwa una make decision ya kwamba hii data itakuwa wapi, kwa kuangalia prefix unajua okay, this half haitakuwepo, I have to deal with this one, then ishafika hapa hii half haitakuwepo, deal with this. So every time inakuwa inakusaidia to choose the path quick. So it's also used in the block headers. So in the Bitcoin, the blockchain header Bitcoin has the macro root. It's always included in each blockchain, securing all transaction within that particular block. Yeah, that's so about the macro tree. So tukaona hapa kuna hiyo root hash, kwa hiyo ndio ile ni kama start tu, na hiyo vitu vingine vinafuata hapa. Transaction inakuwa ni kwenye leaves. Yeah, we could get a more nicer diagram out there, but at least that's what the basic of what macro is na inafanya nini kwenye blockchain at least. So component nyingine au kwenye ukiwa unafanya architecturing ya blockchain, kwa sababu the architecturing when you do about architecturing, it kind of helps you even when you say you want to start your own blockchain network, because all these concept that links you have to kind of have run to them, umezifikiria au unaziinclude kwenye au kama una solution unataka kufanya au unataka kuimplement a blockchain, you have to know how they do validation, you have to know how they form a block, what is included in a block. And kitu kingine cha kujua sasa kwenye unapofanya architecturing ya blockchain, inabidi ujue sasa consensus mechanism gani itaenda kutumika. Najua kwenye introduction tulisikia kuhusu consensus mechanism, Na kwa sababu I don't want to repeat much of the words in the introduction, lakini kwa sababu sasa blockchain tabia yake ni decentralized, distributed. So kama ni kitu decentralized, hapo tu kwenye decentralized, then how do you make decision? Kwa sababu if we have the server, if we have the bank, we have need, we know we have a central way of making a decision, how to resolve some dispute, right? So, but now umefanya decentralization. How does decision happen? How does validation happen and all that stuff? So consensus ni protocols in blockchain networks to ensure all nodes in a centralized a P2P system agree on the set of the shared ledger. Because this is distributed, then we have to find a way the nodes can agree kwenye state ya blockchain. When I say state, ni kwamba blockchain ina, kama tulivyosema, records, same records zinakuwa zinatunzwa kwenye multiple nodes. But kwenye node moja hapo, mfano node yangu mimi hapa, na kulikuwa kuna transaction na sababu mimi nililipa $200 au bitcoin moja kwenda kwa Machuche au Asante. Then baadaye nikasema nataka nipunguze, labda nilipa 0.5 so I can change my balance in my computer. Yes, I can probably do that in my computer, but how can I reflect it to multiple nodes across the network? Kwa sababu those nodes have to agree nilichokibadilisha is correct. And so for that to agree, they have to reach a consensus. They have to find a way to make that decision. Either waikatai the blocks I'm trying to make, or the waikatai transaction I'm trying to make. Now, why toy off the record the ledgers? So they have to have a mechanism to do that. Nature unaita consensus. So different networks different blockchain networks in a different consensus mechanism. I know you heard about yesterday. So today tutaangalia some more in deep, na kwa sababu we have a discussion here, we have an open way ya kuongea kuona hizi different consensus, na I think there are a lot. Kuna ambazo at least zinajulikana na kuna nyingine zinafuata tu some mechanism. Kuna nyingine zipo tu kama hizi ni Banzanite. Lakini yes, so kuna proof of work. So proof of work was the first, maybe was kwa sababu Bitcoin ndio ilianza, labda ndio pia ndo one of the first consensus ambayo ilikuwepo. Na yes, ina security kubwa, is arguably have security kubwa, but I say it's arguably kwamba is energy intensive. Na akisema energy intensive kwa maana yake people have to, or the nodes have to work and the work I'm saying in cryptographical work to calculate the nonce of the incoming or the particular block. Calculate hiyo nonce or that number, inabidi ifanyike cryptographical calculation or computation kupata hiyo number. So the proof of work means we have the miners. So how miners? You have the powerful computers, the GPUs, and what they're supposed to do is only calculating the nonce. For Bitcoin or for blockchains ambazo zipo kwenye hii concept, mostly unakuwa unatafuta hash ambayo itaanza na 4 zeros. So you have to calculate a number ambayo itakuletea hash ambayo itaanza na 4 zeros. So the computers or the nodes have to go there kufanya computation to find that number. So this process is energy intensive. You have to use GPUs. Maybe initially they could use some just powerful computers, but now you have to really have powerful computers to do that. So that's how proof of work it is, to calculate that number, kufanya validation. So each block has to have a validator or a miner to mine it, to include it in a network. I think for Bitcoin, it happens 10 minutes. After 10 minutes, if someone, you can correct me, I think it's 10 minutes, you have to have a new block mined in the Bitcoin. So Ethereum also used the proof of work before. I think before 2022, is it 2022? 2022, yes. Before 2022, somewhere August or September, they were using proof of work, but they shifted to proof of stake. And simply proof of stake, people, how was that mostly what they do hashing? Well, how does consensus increase security percent? Kwa sababu you have to validate ile new transaction, na pia kwa sababu it's energy intensive na kwa sababu ni gharama kuifanya, I don't expect you kufanya brute force kwenye, it's very expensive to do like several trials, like brute force unataka ku break into something kwa sababu like near impossible. You need like a lot of energy to do that. So for security, it's hard to brute force. So for POS, how it does security, they have validators, which they do stake tokens in the Ethereum, or the token, it's called like Ethereum 2.0. So you have to stake ETH. By staking ETH is you have to unakuwa na ETH kadhaa, then you have to stake them for doing validation, and whatever validation happen, you'll be paid or you'll be incentivized for some validation unazokuwa una happen. The security part of it, you cannot, ni energy efficient. The security part of it, ukijaribu kutemper with the network, you lost the stakes that you're having. So na nyingine ni hizi ambazo zinafuata hii the protocol of Banzanite, so include the PBFT. Kwenye hyperledger nyingi zipo, hata wanaofanya PFT ndo I think pia also the proof of authority comes in here, proof of agreement penda kuja hapa. Stellar consensus protocol pia inalai kwenye Banzanite, so they are very fast na they're a little bit low decentralized. Mostly the Banzanite zinapika kwenye private networks. Kama unafanya, if you have worked with the Hyperledger Besu or Hyperledger Fabrics, they use this consensus mechanism to reach agreement. So nimeziweka hapa nyingine na so the examples maybe, so nimesema proof of work is being used in Bitcoin up to now. Proof of stake is being used in Ethereum. It's being used also with the Cardano. So nominated proof of stake it's being used, I think, in Polkadot. So it's a mixture of proof of stake with, I think, is it proof of authority? But the nominated proof of stake is another way, it's another form of proof of stake, and it's being used in Polkadot. Proof of authority and agreement that being used in Hyperledger mostly, I think, in the private networks. For sub, you need someone to authorize, and I think I've seen this one with Hyperledger Besu. So someone has something to add, or someone something to comment, or a good analog of at least I think we are just left one side, which is my final analog with the consensus. You are most welcome here ili tueleweshane zaidi. Yes, so if not, to just see the network participant and the role. So after coming up with the ukishafanya architecture mpaka umeshafika kwenye the consensus mechanism ambayo utaitumia kwenye, I'm talking as someone who wants to create network yake, or when you think of a network, of a blockchain network, you can think in these ways. So you have to think about the nodes. So as I said, nimeongea sana kuhusu nodes. So nodes ni hizo computer ambazo zinastore hizo blockchain data. So we have full nodes. The full nodes store the whole ledger, and the light nodes are stored to some partial data. So we have miners. So for proof of work, you'll have miners, and the proof of stake, you have validators. some proof of authority agreement. You gotta have like I don't remember how they call it in proof of authority, but has to have a core leader of the network. We have the users. So in your blockchain network, shakuwa na hizo nodes, several nodes, shakuwa na miners. You need to have the users now to initiate the transactions, and you need also to have the user to interact with smart contracts, just to create those blocks every time in the network, And actually, for the network, you probably need developers. You need developer who do maintaining, who do the upgrade of protocols. And like Ethereum, we have the Ethereum coders, and I think someone who have heard the cohort, they have the coders who can join the team and stuff. So I'll say that is it for me today. I'll probably come question, ideas, discussions, just to wind up the session. So anyone with something to talk about the network, the users, about developers.
Yeah.
Yeah.
Any questions out there? First of all, before I just chime in.
I think there was one question on the comments. I don't know kama ushajibiwa, or was that an old question by Baraka?
Oh man.
Sijaona hiyo question, labda if you can just read it out loud maybe.
Alikuwa anasema can a private used to create other private keys or parent child? I don't know what he means by that.
I think what he's asking, nahisi alikuwa anauliza kwamba kwenye zile private and public keys, can a private key be used to create what? Another private key? You could have a private key, you could have okay, nitaeleza after niambia kama swali lako bado. When you have a wallet with the private key, you could have more than one public keys in the wallet. So yeah, you cannot create, I mean, a private key cannot create another private key, but you could have public keys, so which are accounts linked to a single wallet. You could have multiple accounts or public keys linked to a single wallet. Yes.
Amazing. I don't think Baraka is still in the session, but that was a great answer. Anybody else got a question, comment, or takeaways?
I guess I can add something hapo kidogo.
Yeah.
The scope of this course again is we're hoping for everyone to come out knowing how to build smart contracts with Solidity. But so maybe you might feel that this part is an overcomplication. Lakini sio kweli. This kind of stuff, getting the basics, will help you become a really good smart contract developer, because you will understand the development environment through which you're developing your products and your solutions. So I remember when I was starting out, I also went the hard way. I started with this kind of stuff, and I felt it was unnecessary, but it's very important, and it will lead you to getting from 0 to 1 much quicker and being much better at this stuff. So that's all.
Yeah. Yeah, go on, Mark.
Yeah, I was just
Hello?
saying that's so true. That's so true. I mean, at least for when you start. Actually, when I started, I just wanted to see smart contracts coming up to life, and then I noticed I have to understand the basic of blockchain. Like, then I have to come back and start reading this stuff. But it's good when we start in this way, having these basics. And I think after like 7 days, when we wind up with this, we'll have good time in the solidity. And it will make more sense when you hear the transactions, or you hear the public and private keys of the smart contracts and particular transactions happening. So it won't be like a shock or something. Yeah.
Awesome.
Yeah.
Awesome.
Hello.
Yes.
Sijua kama nasikika,
Unasikika? Nani anataka kuongea?
na mi naitwa Salim Kachemela.
Karibu kaka Salim.
Yeah. Sorry, nimesikia hapo we'll be working with Solidity. Sijajua, at first I kind of thought tutatumia Rust kwenye this training. So sijajua kama we're planning to change the technology ama ni vipi?
Yeah. So the goal is always to end up on Rust because that's the future we believe. Lakini kulingana na zile responses za kwenye ile form tukaona tutengeneze schedule ambayo ita accommodate watu wote ili tuweze kuwa fast track kwenye Solidity na kutoka kwenye Solidity uingie kwenye Rust. So if you check out our Notion page, kuna schedule pale ambayo imeonekana pale. I think it should be like basics of Solidity for I think couple weeks, 4 weeks or so, and then from there tunaingia kwenye basics of Rust and then go from there. Lakini we are hoping sasa by the end of like the cohort hiyo ya Solidity yenyewe, like we can develop like smart contracts, build real world solutions. Like, of course, it's going to require a lot of like hard work as well and extra time and effort. And that's the reason why tunakutana physically on Saturdays as well, so we can have hands-on sessions. So sijajua kama ninajibu swali lako hapo kaka Salim.
Yeah, imejibu vizuri sana swali langu. Also nilikuwa naomba kuuliza kitu kingine kidogo, especially kuhusiana na the live session ambayo itakayofanyika, the physical meeting. Sijajua, how do you guys plan to accommodate watu ambao wako a bit far from Dar, for instance, labda anaweza kama mtu labda yuko Mwanza au wapi, yani how will that person be in sync na hiyo activity ya Jumamosi? Have you guys considered that?
Yeah, so from our responses, most of the guys walikuwa Dar es Salaam, lakini I think that's a great idea, and I think that's something we'll definitely consider. Maybe if you can like maybe have like a live session as well there. I don't know if it's gonna be as useful kwa watu ambao wako online, lakini I think it could be an idea we could definitely consider and set up pale hiyo siku ya Jumamosi. Au mnaonaje mazee kina Asante Marenga Victor?
Nimekaa mimi mwenyewe nafunga safari ya kuja Dar es Salaam, so kwa wale wenzangu wa mkoani, we definitely try to accommodate that. I don't know how we can do it, but throughout the week maybe we can live stream some of the session, record some of them ili kila mtu aweze kupata nafasi ya kushiriki. And all the activities tutakazofanya we try to combine, but everything we cover kwenye hizi sessions za online. For the live ones it's more like try to kind of like ask in person questions, sababu unakuta saa nyingine hivi virtual unakuwa una miss vitu vingi. So for you guys, with technology we have wifi and the internet, so we can always try to bring you guys into session as well. So kama wewe unaishi mkoani, just DM us on the group and we'll see how we can accommodate you, tutoe ratiba tuone which one will fit for you, and then you can let us know kama utaweza kukaa muda wote, kwa sababu we're going to be online, we're going to be together maybe for 3-4 hours. If you want to really join, I'm sure we can make it happen for you. Salim, we check it kwenye DM and then we'll see how we make it happen.
Yeah, sure. Because the reason I'm saying this, myself niko Dodoma, so sometimes it can be possible for me to come, sometimes it might not be possible. Ndo maana and I don't want to like lose hichi kitu. Sasa I was actually trying to think of a better way ya na mimi kuparticipate kwenye hii session, ndio maana nikauliza hili swali.
Got you. Kwa mwenyewe niko Dodoma, so Dom City stand up. Kama unataka tuende wote Dar es Salaam, let me know. We make it happen. If you can't,
Yeah.
yeah, if you can't, we can try to find a way. Tukiwa pale tutakuwa tuna ratiba ya siku, kwa tutaweza tukafanya both virtual and physical. And maybe kama mtu atakuwa anafundisha kitu anafanya hands on, we'll try to have the computer there as well, tuwe na Zoom session ambazo zinaenda hand to hand with the live session, so we can also like keep you guys like locked in. But if you also want to make that trip, at least for the first one, it could be cool also to meet other people. Yeah, I don't know what you're thinking, so let me know, we can plan.
Yeah, sure, I actually plan kuja, lakini the first session I think this week I miss. Maybe the second session I'll probably be there.
Amazing.
Siwazi bro, tuko
Yeah.
pamoja. If anything maybe sana kama kuna mipango ya misosi hapo unaweza ukayumba hapo ukakosa, lakini kiimani, kiteknolojia tutakuwa pamoja bro.
Sawa, haina
Yeah.
shida.
So yeah, thanks everyone for joining. Just a final word from my side. I think like I mentioned mwanzo pale kwa watu ambao labda mkuwepo, like we're planning to like make this as fun as possible and try to organize like something like a hackathon or like a prize pool at the end where like umetengeneza smart contract imekaa, like you design like a nice front end imekaa, something that actually works, and kuna prize pool, like people can get like prizes for deploying something on a certain chain that we say, hey, we're going to work on, for instance. Also, personally, I think this is very, very important kwa ajili ya kukuza the tech space and development space kwa kibongobongo na Tanzania, and putting us on the map. I think there's still a huge gap that we need to cover for Web3. So if you guys can do a huge one and invite other people that you feel like would be of much value for this course, please do, and we invite kwenye cohort waweze kujoin, manake tujasogea sana. I think it would add much value to them. And yeah, that's just it from my side. I don't know if the other guys have anything to add up or before we wrap up.
I was just gonna say, just to add up on that, ile session ya last week alofanya Karim na leo, there's so many connections. So if you missed that one, go on our YouTube channel, check it out, and you'll see how we're connecting from like what a blockchain is now, what tumejifunza leo in terms of like transactions and why it's important, what's hashing and nodes and validating and knowing like how to kind of like set up networks and vitu kama hizo. So as we keep going, everything will make sense. So yeah, feel free to go back and like review these materials. I know they're long sessions, tunatumia kama saa zima, but all this will make sense the more we go. So these materials are meant to live forever with the internet and all the things we have. So we'll share even tools za kujifunzia. This is a class, guys, so we want to take it very seriously. We'll definitely give certifications at the end, because if we can build something at the end, you're qualified, And the good thing about software, it's version 1, version 2, you can always keep learning and keep building. So let's grow this community together. Let's keep growing with the sessions as we go, and understanding ikua will make amazing things. So this is Duniayetu. Start the conversation on the WhatsApp group as well if you have any more questions, or you want something specific to learn more if we have not covered.
Yeah, also if you have any feedback on like the processing, on like how we're running the calls, or like what we can improve, what we can change, feel free to like just being in the group, or if DMing us, so kipengele, like we'd love for it to be as interactive as possible, and get feedback there as well. So yeah, hopefully you can see more faces next time, and we invite people. I feel like mtu mmoja hapa, kila mtu invite mtu pale. I feel like this can add a lot of value to all of us as a collective in Tanzania, and getting all of us on the space there, because there's so many opportunities going Web3, and I think this is just the start, So congratulations again to everyone that joined. and tukutane tena kesho mida ile ile saa 2, and Wednesday pia saa 2. Jumamosi tutakutana physically and compile all that we learned from last week and this week, since we didn't last week. So yeah, thanks everyone, and tukutane kesho hiyo saa 2.
Yeah, thank you.
Have a good one, guys. Enjoy your week.